Hello, Pre-Calculus kids. Today we start an adventure into the double angle and half angle formulas, the identities that go with those. This is section 11.4. There are 5 sections in the unit, so one more section and then we'll have a test. But it all has to do with all of these crazy formulas and identities that we've been talking about. I gave you in section 11.3 a whole sheet that has the list of all the possible identities. This section talks about the double angle and half angle formulas. So doubling something or halving something is what you're looking at, and they happen to be trig functions. So here's the double angle formulas. You have one choice for the sine of 2 theta. It's 2 times the sine of theta cosine of theta. For cosine double angle, you have actually 3 choices, depending on what the problem looks like. The one that you most commonly use is this first one. So that's listed first, and then you could possibly use one of these 2 forms that are also equivalent to that. Tangent only has one choice as well for double angles, and this is what its formula looks like. When you get over to these half angle identities, you're taking half of whatever an angle is. And these square root problems, 1 minus the cosine over 2, 1 plus the cosine over 2, 1 minus the cosine over 1 plus the cosine, these are all the formulas in square roots that you've got, but it could be the positive part of it, or it could be the negative part of it. It's not going to be both. It depends on what quadrant you're located in. And I spent a lot of time because there's discrepancies amongst the math people as to whether it should be positive or whether it should be negative. So I spent a lot of time researching this over the last couple days. And it's funny because you watch one YouTube video and they say to do it one way, and then you watch another video and they say to do it a different way, and you look at one textbook and they tell you to do it another way. And so it got really confusing to me, and I tried to make it as simple as I can make it for you all. So here's what I found and what we're going to use. Alright, so, and this is included if you download our stuff. Where are the half angle identities positive and where are they negative? And we're going to base it all, some books base it on where theta is, and some books base it on where theta over 2 is, where the half angle actually is located. We're going to go with where the half angle is located. And here's our chart. So if I'm looking for the sine of theta over 2, and I'm in the first quadrant, it's positive, second quadrant positive, third quadrant negative, fourth quadrant negative. You got the idea of how you can do this. So I put a chart together for us to be able to help. Sometimes they don't tell you specifically what the angle is, they just tell you the quadrant it's located in. So if I take, and my angle is located in the first quadrant between 0 and 90, and I half that, half of 0 is still 0, but half of 90 is 45, I'm still in quadrant 1 because I'm between 0 and 45 degrees. If my original angle is in the second quadrant between 90 and 180, and I half those values, I'm between 40 and 90, I'm still in the first quadrant. If I take the angle is in the third quadrant between 180 and 270, and I half those values, now I'm between 90 and 135, so I'm in quadrant 2. And if my original angle lands in the fourth quadrant, then if I half my values, I'm still in the second quadrant because half of 270 is 135 and half of 360 is 180. So I'm in quadrant 2. So we're going to use this chart to go by, and I think actually on the flip math video there might be one mistake in the midst of how he did one of the problems. But for our purposes, here we go. There's our plus or minuses and how we're going to divide them. You'll see as we apply it, it'll make a lot more sense. All right, so here's our introduction. The first thing that they're going to say is this a true statement or not? So I have the sine of 100 over 2, 100 degrees over 2, is equal to plus or minus the square root of 1 minus the cosine of 50 over 2. Is that what it would look like if I were to take this identity and apply this sine, this rule to it? So let's see. If I have the sine over 100 plus 100 over 2, sine of 100 over 2, and I expand that 100 over 2 equals plus or minus the square root of 1 minus the cosine of theta, of cosine of x. 1 minus the cosine of x. Well, what number's in the x place? Well, in the x place, that's the numerator. So that would be 100 all over 2. And is that what they gave me here? And the answer is no, because they said here that this is 50. And really it's supposed to be whatever this x value is, which is 100. So this would be a false statement. That is not true. So that's the first thing you're going to see is this the right expansion of that identity? And then the second thing you've got is something like this. Find the exact value of the cosine of 105. And what you need to do is you need to think back to this crazy chart that we did way back when. Remember this chart? You still need to have this handy. And again, I copied it one more time as I put the notes together for this so you'd have it. But you can see on here 105 doesn't work. 105 is not one of our numbers. So if it's not one of our numbers, I need to work it into somehow being something that's actually on my chart. And so if I think of 105, if I were to double 105, the cosine of 105 degrees, I could say that that also would be the same thing as the cosine of 210 degrees divided by 2. Because if I take 210 degrees and divide it by 2, I get 105. And so I can see that that's what this is. Now this now lets me apply my half angle formulas over here. So I can apply this cosine of x over 2. So the cosine of 105 is equal to the cosine of 210 over 2, and now I'm going to use my expansion of this. It could be positive, it could be negative, we'll talk about that in just a minute. And I'm putting in my expansion. It's the square root of 1 plus the cosine of x. Well, what number's in the x place? That's my numerator, that's 210, and that's on my chart. That's the whole reason I'm doing this, is so I can put it as something that's on my chart, over 2. Alright, so let's talk about the quadrant that it would be. So the quadrant, we said we're going to base all of our quadrants off of the half angle part, theta over 2. This is theta over 2, right? Well, theta over 2 in our case is equal to 210 divided by 2, so that's 105 degrees. Well, where is 105 degrees? 105 degrees would be in quadrant 2, and this is cosine. So I'm going to go to the chart that I gave you right here. The cosine of theta over 2, if it's in the second quadrant, is negative. And so that's the fact that we're going to use. We're going to use the negative square root of this to continue on. So this one's going to be negative because it's cosine and it's in the second quadrant. So that's telling us whether we're positive or negative. So we know we're negative. Negative. Then I'm going to take my square root. So I got this part figured out. I've got 1 plus the cosine of 210. Now I'm going to this chart and I want to know what's the cosine of 210. So if I come down here, 210, go over to cosine, it's a negative square root of 3 over 2. So negative square root of 3 over 2. And then I have that whole thing being divided by 2. That is a messy, complex fraction, but there's a trick to this. They don't show you the trick on the flipped math video, but I'm going to show you the trick. The trick is to take whatever the denominator here is, and you're going to multiply the top and the bottom fraction by that denominator number. So in our case, we're going to multiply by 2 over 2. See how my denominator is 2? So I'm going to multiply the top by 2 and the denominator by 2. And watch and see what happens. It's going to save us a whole lot of work, because if I have my negative square root, 1 times 2 is 2. The square root of negative square root of 3, this is going to be a plus and a minus, so this is going to be a minus in here. The square root of 3 over 2 times 2 makes these 2 cancels out. So I have just a square root of 3 that's here. And then on the bottom, I have 2 times 2 is 4. Now, was that a legal math move for me to do? Can I just arbitrarily multiply by 2 over 2? And the answer is yes, because 2 over 2 is just a form of 1. So I've just multiplied it by 1, but it's a funny looking 1. So I haven't changed the value of what I started out with, I just changed the way it looked. And happy for us, what's the square root of 4? The square root of 4 is 2, so I have my final answer, negative square root of 2 minus the square root of 3. Yes, that's hot and messy. All over 2. And that's it. That's your final answer. All right. Going on to the next ones. Now, these make you have to create your own reference triangle. We've done that before with other things that we've seen in this particular unit. But my first job is to figure out what the reference triangle would look like. They tell me it's in quadrant 3. So I'm going to set it up in quadrant 3. Here it is. There's my theta. And they tell me that the sine is a negative 1/4. Well, sine is opposite over hypotenuse. Hypotenuse is 4. Opposite is 1, and you can see this is below the x-axis, so it's going to be a negative 1. And so job number 1 for us is to figure out, well, what's the other missing side? Well, the other missing side is an x value, so I'm going to set up Pythagorean theorem. I'm going to have 4 squared equals negative 1 squared plus my x value, whatever that is, squared. And then I am squaring it out. So 4 squared is 16, 1 squared is 1, plus x squared. I get x squared is a square root of, it's x squared is 15. When I square both sides, then x is going to equal the square root of 15. So let's put that up in our reference triangle. And when I put it in the reference triangle, you can see it's to the left of your origin, so it's going to be a negative square root of 15. Now, if it were a number that actually could tree out and you could figure out what the better representation is for that square root, you probably want to do that. And you'll see that with some examples that you'll see in the video and things that we'll do when we do practice problems together. Like I'm saying, like say it was a square root of 20. The square root of 20 you can tree out to a 2 times a 2 times a 5, and then it becomes 2 square roots of 5, and that's what you want to do. This one, 15, is 3 times 5. Nothing pairs up, so you can't take anything out. So that's the best you got. All right, let's move on with the problem. They want the sine of 2 theta, so I go to my rules at the top of the page. I have one choice. Yay, one choice. So I just put in my values. So sine of 2 times theta, sine of 2 theta. And again, you can call the angle x, you could call the angle theta, you can call the angle alpha. Oh, by the way, in one of the last lessons that we did, we had a symbol that was like a Y kind of thing, kind of like this. It's called a lambda. Sydney helped me out with that. I had never seen that before, but she said it's used a lot in physics. So it's called a lambda. So if we ever see that one again, now I'll be smart and I'll know the name of it. All right, so anyway, this one's theta. My formula says 2 times the sine of theta times the cosine of theta. And so what I'm going to do is I'm literally going to go to my triangle and figure out those values. 2 sine of theta. Well, sine is opposite over hypotenuse, which you already know that over here, is a negative 1/4. Cosine is adjacent over hypotenuse. That's going to be a negative square root of 15 over 4. And then all you need to do is multiply those things together. So, first thing I see is I've got a negative times a positive. Gives me a positive, so I don't have to worry about those negative signs. I have, this is technically 2 over 1, so 2 times 1 times the square root of 15 is 2 square roots of 15 in the top. In the bottom, I have 1 times 4 times 4, so I have 16. These outside guys can simplify, so I can cancel them. He's a 2, he becomes an 8, and I get the square root of 15 over 8, and that is my final answer. Then I get to, this is the hardest one on this sheet, then I get to the second side here, and this one is the tangent of theta over 2. Well, the tangent of theta over 2, if I go back up to my formulas, is this guy over here. We're going to use this one. We have to figure out, though, the quadrant, because we need to know whether it's positive or negative. But let me just write it out here first. We've got plus or minus. We have the square root of 1 minus the cosine of, well, theta, we'll keep it as theta, and 1 plus the cosine of theta. And that's what I'm going to use, and I'm using this reference triangle to be able to figure this out. But let's talk quadrants. If I look at this, what quadrant is that triangle located in? And you see it's located in quadrant 3. So I'm going to go over to this sheet that we started with, and if I'm in quadrant 3, between 180 and 270, and I half it, now I'm looking between 90 and 135, which is really quadrant 2. You see how this can be kind of confusing, right? So if my triangle's located in the 3rd quadrant, and I half the angle, now my angle's in quadrant 2, I'm using the rule for quadrant 2. Tangent of the half angle in quadrant 2 is negative. And so I'm going to use this one as the negative, not the positive, so I can continue on with that. All right, then I've got, in my square root, 1 minus the cosine of theta. Well, go back to your triangle. Cosine is negative square root of 15 over 4. Negative square root of 15 over 4. And in the bottom, continue that down a little bit there, I get 1 plus, same thing, negative square root of 15 over 4. And you say to me, that is mighty ugly, Wenner. What am I going to do with that hot mess? And I say to you, do not fear. You are going to multiply by our trick. In this case, our denominator is 4 over 4. All right, so if I do that, that's going to create for me a negative square root of 1 plus, actually I should probably, I guess we can do it all at once. If I have 4 times 1 is 4. Negative negative is plus. And the square root of 15 over 4 times 4 cancels the 4's, and I get the square root of 15. There's your new top. All right, on the bottom, I'm going to do the same thing. Multiply by 4. 4 times 1 is 4. Plus and negative makes this a minus. And then I get the square root of 15 over 4 times a 4. 4's cancel again. I get a square root of 15. And that, my friends, is your final answer. Also, by the way, this is another section where they give you these crazy square roots. And yes, you can rationalize this. And you'll probably see in the flip math video that they actually do rationalize it. But I am perfectly happy if you come up with this answer right here and toss that on your paper. That's good for where we're at. All right, here come the last couple. These are back to verifying. Remember those kinds that we've done before. And so what you need to do is you need to work with your identities and see if you can make the two sides equal each other. So you can work on the left, you can work on the right, you can work a little on the left, a little on the right, but in the end you want them to match each other. And they're not going to give you, if they're telling you to verify it, they're not going to give you ones that won't work. So you've got to use the identities. And lucky for us, the sine of 2x has one choice and one choice only. It is 2 sine of x, they're using x's, cosine of x. And I can see if I'm on the left, I don't have anything with tangent. So I'm going to change tangent into its sine cosine deal because this side has sines and cosines and no tangents. So tangent is sine over cosine. And I have 1 plus. Now notice I've got choices for the cosine of 2x. I can use the squared, guys. Cosine squared minus sine squared. I can use 2 cosine squared minus 1. Or I can use 1 minus 2 sine squared. I'm looking at the formulas at the top of the page. But if I look here, see how this has a denominator of cosine and this one doesn't? This cosine must cancel out somewhere along the line. So I'm going to use the one that just has cosines in it and see what happens. And again, I'm choosing that because this side has a denominator of cosine and this side doesn't have any denominator at all. This cosine must cancel out. And the only way it can cancel is with another cosine. So let's look at the formula. It says 2 cosine squared x, or theta, whatever, minus 1. This piece here is what is equivalent to the cosine of 2x. And you'll see that, funny enough, look at that, woohoo, do a little dance, the ones cancel out. And so here's where you're now at. You've got 2 sine of x, cosine of x on the left. You have a sine of x times a 2 cosine squared x, and then you've got this cosine of x on the bottom. All right, if you see this, you got the 2, you wanted a 2. You've got the sine, you wanted a sine. You have 2 cosines here that's going to cancel with 1 on the bottom, and guess what? You just verified that because on the left you've got 2 sine of x, cosine of x, and on the right you have a 2 sine of x and 1 cosine of x left. All right, so that is a verifying. Number 6, our last one, here it comes. This one I have, on the right hand side I have 1 plus the sine of 2x, and again we only have one choice for that and we're going to expand that out. But this one is like the sine of x plus the cosine of x, and you've got 2 of them. I'm going to write it just above here. You've got 2 groupings of sine of x and cosine of x, and guess what you're going to have to do with those guys? Right, you're going to have to FOIL them. All right, so let's FOIL them. It's going to be a big old long thing. I'm going to kind of condense it a bit, but sine times sine first, it gives me sine squared x. Sine times cosine just gives me sine times cosine. My insides, cosine times sine, gives me, I'm going to put below right here, cosine of x, sine of x. And my last give me cosine times cosine, so that gives me a cosine squared x. That's all my left-hand side when I FOIL it out. And on the right-hand side I have 1 plus The sine of 2x, I've got one choice. It is 2 sine of x cosine of x. Can I fit it there? I did it. Okay. All right, now you're looking at this and you're going, there's no way that that left-hand side can possibly equal that right-hand side, except some of my savvy students, because I know you're smart, might realize that I have a sine squared x plus a cosine squared x. And you might recognize that from back in the day of Pythagorean identities, they equal 1. All right, so if I have 1 plus, that gets rid of these two, I have a sine cosine and a cosine sine. They're being multiplied together, so it doesn't matter the order they're in. You have two of those same things. You have two of the, you can write it as sine cosine, you can write it the other way also. And if you look, that's what you wanted. There you go, you got it. You're done. All right, so the trickiest part, I think, in this particular section is probably trying to know what quadrant you're in for the half angles. And like I said, I tried to make it as simple for you as I could by putting a chart together, and this is the chart we're going to go by. It may mean that some of the answers on the flip math video are wrong. We're just going to go with what we say. So I'm going to give you also some practice examples to go with the practice problems. I hope you're doing well, and if you have any questions, as always, give me a buzz. You can email me, and I hope you're doing well. I'll talk to you soon. Bye.